This time on the show, building an FM receiver with GNURadio Companion, and so much more. This episode of Hak5 is brought to you by Domain.com.
Hello, welcome to Hak5. My name is Darren Kitchen.
I'm Shannon Moore.
It's your weekly dose of Technolust.
Welcome everyone to our humble abode.
I am
and our burlesque show.
No,
starting now.
I'm
Go Darren! Woo! Yeah!
I'm representing our fallen hero.
Who?
Flappy Bird.
Oh.
You get it? Fallen hero.
Oh my gosh.
All right.
That was so bad.
I know.
So bad it was good.
Dude, I'm playing it on my phone. Look at this. This is ridiculous.
Wait,
I've
really?
got yes.
Oh,
got
you have to.
Tiny bird. I know.
You have to lean it towards the screen.
Oh
there
yeah,
we go.
they'll be
Okay.
able. Yeah.
I
Good luck
can
with
see
that, Paul. B-roll time. Oh,
Whoa.
didn't even get one. I know.
It's because you suck.
What? Oh. Oh. Yeah. Nope.
So what are we doing today?
We are continuing with our series on software-defined radio.
Woohoo!
With diving into GNURadio Companion.
Yeah, you made this thing work.
I learned a lot of things, and we will now dispense that knowledge to you in audiovisual form. So please follow along at home, grab your SDR dongles, and whip out your copy of Pen2 because it's time to get GNURadio on.
Yay!
Okay, so seriously though, picking up from last week, we went through the RTL SDR.
Yes.
Package that allows you to do cool things with these little dongly guys here.
$20 dongles.
Woohoo! And we can, which are back in the Hack shop by the time this airs, so that's good.
Oh, that's good.
And
I know we sold out.
which is really cool because I'm glad that everybody's following along. It's fun. And so we've gone ahead and tested to make sure that GNURadio or that the Realtek dongle works. We've done the RTL test. We've done a little stuff with like the RTL FM stuff. And now let's go ahead and actually do it by hand and build ourselves an FM radio receiver in GNURadio.
Yay! I was really excited to do this so we can actually see kind of a back-end idea of where we're going to input all this information.
Right. I mean, GNURadio Companion is really sick because it takes together, it puts together all of these different modules that essentially would be big pieces of hardware.
Yeah.
And allows you to do it on your computer for like nothing. It's amazing.
It also, I like that they include descriptions for each of the different modules that you get so that it kind of helps you understand everything that's included whenever you want to try to get this radio on.
Right, and I know that, you know, right now our goal is to kind of introduce you to GNURadio Companion and its kind of like blocks interface kind of thing to quickly and easily build a program without writing any Python or C, even though it's going to make it in Python or C on the back end anyway for you. And I know already that we're going to have to just, this would be a 4-hour show if we tried to explain everything when it comes to what is a quadrature and all of those things. So we're going to just kind of gloss over some of the signal theory stuff, which I love, but maybe we'll have a separate
we'll do a whole series
episode
on that kind of stuff.
Because when it comes to modulation, I am like modulating. So anyway, with that, let's just go ahead and dive into the program here.
Yeah,
so this is the file that we had last time.
Yeah, this was the original
file
that we had. So we had a couple of different modules already set up.
Yep, you get your module workspace in kind of the center there, and then you've got all of your blocks over on the right, and you can kind of drill down into any of those and you know, see what's underneath. And then at the bottom, you kind of get your like output. It kind of seems familiar if you're ever used to like, well, pretty much
it's
any
like
IDE.
coding.
Yeah, exactly. It's like whatever.
It's very similar to that.
If you're used to Eclipse or Visual Studio, even AutoCAD looks this way, or at least it used to back when I ran it.
This is what Visual Studio looks like. I know that.
There we go. So let's go ahead and make this program a little bit more complex. So right now, what you're looking at are you have two blocks: your source and your destination. So your source in this case, as we laid out last week, is the SDR. Our Realtek SDR source, and if you double-click onto that, we can open the properties of it. And the only value that we've changed here is our frequency. And in this case, it's 93.6 E6. Now E6 is just 6 zeros, so it's 93.6 million or 93.6 million hertz.
Oh, okay. Hence the 96.3 M that we see right here.
Yes, as in megahertz, as in, you know, we're tuning in on the FM dial. So that's good stuff, and we're piping the output of that very much like we do with, you know, Bash or Linux or whatever programs. We're using the pipe. We can take the output of one program and put it as the input to another. And the same kinds of things here where you draw those lines. And actually we're able to T things where we can actually take the output of something and send it to 2 places. We're about to do that. Let's take a look at where we're going with this.
Okay.
Currently, it's going into this thing called a WX GUI FFT sync. And we don't need to get into what FFT sync is, but it's basically a nice little way to visualize the spectrum.
Ah, okay.
And this is just using the default. So let's go ahead and build this.
Okay.
The shortcut key is F6, by the way, which will make things a lot
F6.
quicker.
Got it.
And
So
it's
it builds
compiling
down
at the
there.
bottom.
Okay, so we have this.
And there we go, and you can see it. And if you actually click on that checkbox in the top right where it says peak hold, in fact, you probably don't even need to do that to notice it. Over there on the right, you'll notice there's like a little bump.
Yeah.
And that right there is a radio station. That's a broadcast FM station.
Cool.
And we're going to go ahead and build a program now. We're going to expand this out so that we can, in fact, tune to that and listen to it.
That's awesome.
And then we could later like record it and other fun stuff like that. But
Okay.
this is going to require adding some resampling, adding some filters, as well as demodulating it. I mean, FM stands for frequency modulation. We're going to get into what the difference between QAM and AM and FM are here soon. But just staying with something that people are probably already familiar with, but not as intimately as this, let's go ahead and start by, I think we should probably do a resample first. And then kind of explain why we need to do such. So actually, why don't we replace that FFT sync with something a little bit more visually interesting? Go ahead and delete that.
Just delete.
Just delete on the keyboard.
Okay.
And go ahead and under instrumentation and then WX, you'll see there's a WX GUI waterfall. Don't go chasing those. It's true that Shannon can do the entire rap.
Yeah, it's true.
It's true.
Yeah.
Tune in
Lisa
her
left our lopes.
Gonna have to tune into her YouTube channel for that.
I seen a rainbow yesterday. Sorry. All right, I'll stop.
So the waterfall is really nice. In fact, you should be familiar with this from SDR Sharp, but it's a really beautiful way to kind of like see, rather than just a bump, but you can see it beautifully over time.
Yes, the
so
colors.
go ahead and connect those two guys.
All right,
and it's really simple to connect. You just click the out.
In.
Yep.
Got it.
And F6 to run it.
F6. And it runs. Ta-da! Ooh, look at that. See, this totally reminds me of like being on a boat and then seeing the sonar.
Aw.
It's so fun. So is that the same channel that we saw earlier?
That is the bump, except now we're seeing it over time.
Cool.
Which is going to really help when we go to tune into it. And this is nice because if we were at like a lower frequency and there was a bunch of other fun things, we could see more of these and then select them. And it's just, I don't know, it's crazy cool. We need to resample this so that our computer can more easily decode all of it because it turns out, a ton of data.
Yeah.
We're getting just the raw samples right off that chip, and it's going into our CPU, and it is going to get overloaded by trying to process all of that information. So we're going to throw 2/3 of it away.
Oh, okay.
It's okay. We're still going to be able to listen to it.
But I don't want to throw 2/3 of it away.
We're just going to have
to
do that. We're just going to have to do. I'm sorry.
Okay.
It's what we're going to need to do.
All right.
So let's go ahead and add ourselves what's called a rational resampler. Okay?
Okay.
Changing the sample size here. And so you would think that the rational resampler would be under resamplers. And you'll actually find something called a rational resampler there, but it's actually a rational resampler base. And that is not the same.
So what do we want?
It's under filters.
Filters, okay. And it's called rational, there it is. Drag and drop, okay.
All right, and so go ahead and take the output of your RTL source and put it into the input of your rational resampler. And what we want to do is go ahead and set your decimation to 4 and your interpolation to 1. 4,
interpolation to 1. Is that it?
Yep, oversimplification is we're getting about 1/4 of this, and now we're going to add a low-pass filter. We'll later be able to show like what the difference is with and without it. But essentially what this is going to allow us to do is clean up the signal a little bit and make it sound better to our human ears.
Oh, yay.
So grab that. It's under filters.
Ah, another one under filters. There we go. And it's called low pass filter, this one?
Yes.
Okay.
And you can see the defaults are already good, except those red ones need to be defined. And we can actually get a lot more complex in the GUIs and how to make these more user accessible. But for right now, let's just go ahead and set some hard-coded values here.
Okay.
For our cutoff frequency, let's make that 100K. So that would be 100,000.
100K. 1,000.
There you go. And our cutoff, or I'm sorry, our transition width is actually going to be 1 million. So that's 1E6.
E6.
There we go. And now we just connect those guys together.
Okay.
And here comes the fun part. Let's actually demodulate some of that information that we're getting in here. So in this case, what you'll want to do is look under modulation. And actually, you can, if you go to the very top, scroll all the way up, and click on blocks, it'll sort them alphabetically, which is really nice.
That makes life so much easier.
Yeah.
Okay. Where am I going? Modulation.
Modulation.
Modulators. Okay.
And we want WBFM.
WBFM.
Receive.
Which one? Oh,
just the one that says
okay.
receive. Yep.
Cool.
And then toss that guy in, the output of low pass filter into him.
Low pass into you. Bam.
All right, and we're going to go ahead and set his quadrature rate to 500,000 and the audio decimation to 1.
1.
So we do want audio out of this. Hit OK.
Okay.
Fantastic. And now we need to resample this again, and we're going to come back to something changed here. So go ahead and grab filters.
Filters. And another resampler?
Yes.
What was it called
That
again?
one, rational resampler.
Yeah. There we go. Okay.
All right, and connect those together. The output of that one into the input of this one.
Okay. Uh-oh, my arrow's red.
Yes, and there's a reason for that. You notice that the output is actually highlighted in orange while the input is highlighted in blue. Now those orange and blue have to do with what type of a number this is. For example, if this were a float or if it was complex. And so if you don't make sure those are all the same, then you'll actually get an I/O size mismatch, and that's no fun. So here's the part that's going to save you a lot of time that isn't really mentioned in a lot of documentation. Go ahead and click on your receiver there, your resampler.
Resampler, okay.
And press the up arrow key.
Up.
No, I'm sorry, not go into it, but
okay.
yeah, just hit the up arrow key.
Oh.
Boom, now they're orange. Hit it again.
Now they're both blue.
Now they're blue. So you want them orange. What comes out of WBFM is complex, and we need to make sure that we stay with that the entire time.
Okay.
So now go ahead and double click on that, and we need to give it some values. Did we set the values for the WBFM?
Yes, I believe so.
500K and 1. Okay, well in that case, this is going to be 500 is what we're bringing in. So decimation is 500.
Okay.
And the interpolation is what we're going to turn this into. So 500,000, you know, I guess you could think of it as like hertz. We're going to now need to give that to, well, ultimately it's going to go to our sound card. And our sound card doesn't operate at 500,000 hertz, nor do our ears. So give it something like 48. 48 would be good.
Okay.
All right, and hit OK.
Okay.
And now we can just go ahead and send that to a sync, to the audio sync. So that's under audio.
Boop.
Not under syncs, which would make sense, but yeah,
audio
under audio.
sync.
And the cool thing about audio sync, if you double click on that there, you want to go ahead and it's by default the sample rate. Hit that drop down there. Those are some really good presets. 44.1 kilohertz, for example, is what you would find with a CD audio player, while 48 kilohertz is what you would find with like, I don't know, like a Blu-ray. 22050 is another good example of like tape, and 11025 for
That's cool.
FM.
I didn't know that.
Yeah.
All right. So which one do I want to choose?
You want 48, because that's what we just downsampled this to.
Okay.
And also where it says device name, this is where you could actually say if on your system it's like /dev/DSP. We're talking about Linux systems here. So if you're on Windows or Mac, it's probably already the default for you. You don't have to worry about it. But if you're using ALSA or Pulse Audio, you may need to actually specify the name of the device which operates your sound card. Thankfully, with Pent2, we don't have to do much.
Cool.
So leave it blank.
Okay.
But just to note there, if you're not hearing any sound, check what device you're using.
Oh, okay. Well, yeah, that makes sense.
All right, and so go ahead and hit OK.
Okay.
And let's run this. Oh.
So I got to output that to there,
output that to the audio sync.
All right. Output to there. Now I have a question.
Yes.
Should this be running to both the waterfall sync and the rational
Sure.
resampler?
Well, if you wanted to, we could disable the waterfall sync, and we wouldn't be able to see anything. And you would actually get a pop-up for the audio sync. However, the audio sync doesn't actually have any GUI elements in it, so it'd be the teeny tiniest little window, and you wouldn't really be able to do much with it.
Okay, I see.
So it's probably best to have something coming out, and also it's really a nice verification, because if you're not hearing any sound, you're like, well, is the radio seeing anything?
Oh,
and
that
much
makes
like
sense.
debugging with a program where you may do like a printf or an echo at various stages of, say, your different ifs and loops and statements like that, you might, while you're programming it, print out some debug messaging where you're like, I got here, or still stuck in the loop, and things like that. You can do kind of similar things with that these WX GUI items. I like the waterfall best, but they all have their strengths and weaknesses.
Yeah.
And similar to like how we have right here, we've just got it coming right out of the source into our waterfall. You can move where that waterfall goes. So you could share it with like, hey, what does the waterfall look like after I do the resampling? What does it look like after I do the low pass filter? Okay. In our case, we're looking at the raw signal right off of the device, but we could have split it right after that last rational resampler and see what they both look like.
Okay. All right. I get it.
All right.
So ready to run?
It's fired up.
Okay. So F6. Hopefully it works. Okay. We have a waterfall. Ah! It works! That's cool.
Yeah.
I don't know what channel this is.
It's not
but
super
that's
super
awesome.
loud. I've got the same thing over here. I'm gonna do it with mine. Whoops.
Whoa, that is loud.
Hang on. I actually need to tune mine properly. You're a 96.3. There we go.
Oh wow.
So you notice that there's a little delay in there?
Yeah, there's
This is
an
because
echo.
we're actually using our computers to process this.
Oh, that is too funny. Well, that makes sense because yours has a better processor than mine does.
Right, but it's not that we received the radio signal any different. The radio signal, we're both receiving the same things, and it's attenuating down this little guy and going into our dongles. But
that's cool.
Okay, if you just close that waterfall, it'll go ahead and stop the program.
Stop.
Yes.
Close. Okay.
So there you go. That's a very basic FM
that was cool.
thing. And in
Although
order
it's a lot more advanced than the one that we showed last week.
It is, and like I said, we could really go pretty far down the rabbit hole as far as actual signal theory and what all of these different guys are doing. But what's really, I just want everybody to get familiar with this, to go in and start playing with this. I mean, as we are as well, and learning. And think of it like programming, because it really is. It's just that you're using Lego blocks in this case.
I see why you like it so much.
Because everything is awesome.
It's a Lego! Yay!
What else? What else? There was something else to this, and that was, we want to make this variable, right? So you've now written a hard-coded radio to 96.3 or 93.6. Forget which one it is. Well, that's great. But what if you wanted to? What if you wanted to listen to a different radio station?
Then I would have to go back in here and change it.
Let's add a dial. So this is really cool. We can actually create programs here, and like that WX GUI is really cool because with the waterfall we get those really pretty, we can see over time, and it's got a couple of built-in functions, but we can actually add our own widget elements, if you will, kind of like Qt. You can actually we'd have drop downs and sliders and enter in a number field and things like that. So we can build a program that does stuff. So we could have ones for like gain and sample rate and things like that. So let's go ahead and add one for the frequency. This one's actually pretty simple. All you basically need to do is, you see over on the left how you have that box for a variable? We have a variable called samp_rate, and it's set to 2 million, and that's how, if you double click on RTL SDR source, that same samp rate is actually how it gets its sample rate. And in this case, if we change that 93.6 E6 to FREQ for frequency and hit OK, now we just have to create a variable called FREQ.
Oh, okay.
So go ahead and grab variables at the bottom there. And just a basic variable. Drag that guy in, and wherever you want to put him. And give it a value of freak.
Cool.
Oop, actually, we need to change the ID to freak, sorry.
Pew.
And the value of the ID in this case would be 93.6.
Okay.
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 E3 or E6.
Got to include the millions on there.
Yes, there we go.
Right.
Okay, and so now if we run the program again.
F6. Running. Ha-ha.
It's again tuned into that radio station.
Yeah, that's cool.
Okay, close this.
All right.
All right, and so now we can add a slider element that will allow us to actually change that variable.
Cool.
So if you look under WX GUI elements, I believe it is, over on the right.
WX GUIs. I'm all the way down. Let's see. I don't see WX GUIs.
It's like widgets. GUI widgets.
GUI widgets.
And then under WX, you're going to find a WX GUI slider.
Slider. Okay.
All right.
Got it.
Bring that guy in.
Okay.
And double click on him. And go ahead and change the minimum to, I don't know, 80 E6.
80 E6. Okay.
And change the maximum to, I don't know, 120 E6.
20 E6.
Sure. That looks pretty good. And then hit OK. Oh, copy. You see where it says ID, variable underscore slider underscore 0? We're not going to be very creative. Let's just copy that and hit OK.
All right.
And now when you go over to your variable FREQ, go ahead and into the properties there. And instead of the value, 93.6, whatever.
Change this to the slider.
Boom. That's it.
Oh, I get it. Okay.
Yep. And let me just make sure your slider has a default value, right? Does it?
Default value 50?
Let's make that 100 E6.
100 E6. Okay.
There we go. That makes more sense. Great, because it's between 80 and 120.
Cool.
So
and it's
now,
not red anymore. Okay.
Go ahead and run it.
Okay. Ooh, this is fun.
All right.
Ooh, staticky.
Not seeing a whole lot here, are we?
No.
But notice that we have a slider at the bottom.
Oh.
And it says 100.1.101.6. Now this is where you say, notice as you move that slider, you're seeing the waterfall change, right?
Yes.
So right now, stop moving for just a moment.
Okay.
We'll actually be able to see, can we see two next side by side? No. A moment ago I thought you had two. Maybe to the left?
I think there's two right here.
Yeah, there you go.
Look at it.
You can
there's
actually see the two different. Yep.
That's awesome.
And now you can actually scan for them.
That's cool.
Now we're listening to 101.6.
I'm going to do it all sorts of crazy style. Let's see. 107.
I had better results down at the bottom, like in the 93, 94.
I'm going to find one. I want one. Oh, there we go. Haha. Oh, wait. Isn't that the same one we were on earlier?
It's coming in really well. I mean, what can I say?
That is cool.
The airwaves are just tuned to them.
So can I do the same thing for AM as well?
That's what I was kind of getting at, is the beauty of this,
so cool.
these little building blocks here is now that you know how to do this and add the sliders, boom, Bob's your uncle, you can just go ahead and change all the variables to be things that you can slide around and enter in. And you don't have to do FM modulation. You could do, you know, AM. You don't have to go to the audio output. You can go to a WAV file or a hard drive, right? And in the future, we're actually going to be able to do some IQ stuff where we actually take out bits and say, for example, where did it go? I lost it. We have some fun. I have some fun toys on 915 megahertz that we'll be able to decode and do replay attacks on to take over. My favorite thing to take over.
What?
Drones.
Oh yeah, those. Yes, that's awesome.
Cool. Okay, so that's a whole lot of stuff. We should take a quick break, but when we get back, we're gonna have the Technologist photo of the week. Doesn't matter whether you use a sample rate in megahertz or gigahertz, when you get that killer idea, you need to snag yourself a domain name and web hosting fast. And with Domain.com's quick discovery system and easy checkout process, you can have your website up and running in no time. I love the guys over at Domain.com. They're so affordable, reliable, easy to use. I have set up websites in moments with them, and their social media presence is second to none. You can tweet them at Domain.com and see why it's such a fun place to do business. And the guys over at Domain.com are huge fans of Shannon and I and Hak5, and they want to hook you up. So use the coupon code HAK5 at checkout and get yourself an extra 15% off. When you think domain names, think Domain.com.
And now it's time for the trivia question of the week. Last week's trivia question was, what was the first well-known encryption machine? And the answer was the Enigma. This week's question is, which tech company derives its name from a mythical creature? You can answer that at hak5.org/trivia for your chance to win some Hak5 swag. And it is now time for the Technolust photo of the week, and this photo is from Silver Moonshine. He said, when watching last week's episode of Hak5 and the trivia question was asked, I was at work, I entered the contest on the site, but I decided to send a picture too. And this was about USB. What does that stand for?
Yeah.
So his girlfriend is a tattooist and gave him a USB tattoo. That's so
nice.
cute. I absolutely love it. So you can share your pictures if you want over at email feedback@hak5.org, and make sure to use the subject line Technolust so that we can find them real nice and easy. I love that picture.
Yeah.
Cute tattoo.
Awesome, awesome stuff. Hey, are you into playing multiplayer in Notepad? You can. Just want to mention that over at irc.hak5.org. I've been hanging out there a lot lately, and I would love to see you.
I love our IRCs.
So come on by. Hey, we were talking about in the last segment about how this can be expanded on to do all sorts of different things.
Oh, yeah.
I picked up a new toy recently. Another
Let
one
me guess. Oh wait, a drone.
Of course it's a drone. What do you think I would be picking up? I mean, come on. You know me by now.
Oh no!
Oh man.
Oh, it's okay. He landed right up.
But check out, we started
Whoa!
perusing around the spectrum. What do we get here? Yeah.
So we're up at 911 megahertz. And we can see, so I'm assuming this is the frequency that is coming in on. It's like pulsing to the...
Given the fact that on the bottom of the device it actually says FCC ID and it says frequency 915 megahertz.
That's awesome.
Yeah. So anyway, I would love
really
to
cool.
expand. I would love to expand upon this series and find a way to go ahead and demodulate that into whatever it is, on-off keying, FSK, whatever the thing may be,
I'm
and actually
so
figure out what
excited
the binding protocol is, and then take over drones in the sky.
You know, we should do a feedback episode just about like SDR, because I've been getting a lot of really good feedback.
So yes, join us on Hak5 forums. So go to hak5.org and join us on the forums. We've been doing fun SDR stuff there. And yeah, just get involved in the community and, like us on the FaceTube.
Yeah, absolutely. I went through like 700 emails this week. Feedback@hak5.org is our email, and then we are also on YouTube, like you said, youtube.com/hak5.
That'd be the one.
Okay, I was kind of guessing there, but I
the
figured
one
it
and
was
only.
right.
Yeah, really, thank you guys for supporting us in that way. If you want to continue supporting us further, feel free to head over to hakshop.com. It's the place where you can find sorts of cool hackery gadgets, including the SDRs. And so we really appreciate your support over there.
And then hak5.org/follow. That's where @Hak5Darren and @Snubs and he never uses the Twitterverse and Google Pluses. Google Plus.
He being Paul.
Yeah, that's where you can find all of our links.
Yeah, great community on Google Plus too.
Yay.
So anyway, with all of that, really looking forward to hearing your feedback on this one. I can't wait to get into the next chapter with the SDR stuff. So let us know what you think. And with that, I'm going to remind you once again that I'm Darren Kitchen.
I'm Shannon Morse.
Trust your Technolust.
Whoops. Oh, there it goes.
That was an expensive one.